So products to sums, and we'll look at sums to products as well. So as I say, not actually in the course as such, it's basically a rearrangement of formulas that we've already looked at. So if they ever do want you to use them in an exam, they might give it to you straight away, or they might have a question where they get you to derive it in the actual question itself. So here's the first one. 2 sine A cos B is the sine of A plus B plus the sine of A minus B. So if it was in a test and they wanted you to derive it, they might say, oh, part A, prove. That's that. And hopefully you can see where it comes from. If you expand out the sine A plus B, you're going to get sine cos sine. Right? But the other one will go sine cos minus cos sine. And so the cos sines cancel and we end up with the 2 sine cos. So that's where the formula. So it turns a product of 2 trig functions into a sum of 2 trig functions. And then there's a similar one, cos, which of course must have come from the cos formula, because that goes cos, sine. So if we add those ones together, we'd be left with the 2 coses. And then there's a sine, which would be when we subtract the 2 coses together, because the cos would subtract the cos, leaving you with the sine minus the sine. So anyway, that's how you would derive them. You'd basically expand out the sum and difference of the 2 angles in the cos formulas or the sine formulas. And of course, which ones to use, I would hope would be obvious, because if you had to do the sine cos one, well, it had to come from the sine formula, because that's the one that goes sine cos. Whereas if it's cos or sine, it had to come from the cos formula, because that's the one that goes cos, sine. Let's use one. So here we go. Here's a product of 2 trig functions, and it's simply saying, hey, rewrite this or express this as a sum or a difference of 2 trig functions. So it's cos sine, or sine cos, whichever way you want to say it. So it must have come from the sine one. I'm just going to rewrite it so it says sine cos. I don't know, just the way my head works. I like seeing it as sine cos. And so then I know, oh, okay, it came from the sine function, and one must have been where it was the sum of the 2 angles, and one must have been when it was the difference of the 2 angles. And so I know it's sine x plus 5x plus sine x minus 5x. And then I get my answer, sine 6x plus sine of negative 4x, but negative 4x looks a bit messy. And so then we remember, sine, odd or even function. Think of the graph. Think of its symmetry. Odd, yes. Has the rotational symmetry. So therefore, the sine of minus 4x would be the same as minus the sine of 4x. So I think that just looks a little bit neater. I mean, they'd have to still mark you right, I think, at sine 6x plus sine of minus 4x. Let's do this one. Okay, so this is a cos, so it must have come from the cos formula. I wanted 2 lots, I've only got 1 lot. So the first thing I've said is, well, that's half of 2 cos. So it must have come from the cosine formula. So in one of them, I'd be adding the 2 angles. One of them, I'd be subtracting. Now, if I'm left with cos, that means it's the sines that disappeared. Thus why it's a plus in the middle rather than a minus in the middle. 5 plus 3, of course, is 8. 3 minus 5 is minus 2, but again, that looks a bit messy. Cos, odd or even? Yeah, so if you think of that graph, you could fold the cos graph on itself. So cos of minus 2 theta would be the same as cos of 2 theta. All right, so we had to work out 2 sine 45 cos 15. Now, sine 45 is easy enough because it's a 1 on root 2. But if we don't know the exact value of cos 15 straight away, yes, we could go and work out cos of 15 and then do this problem. That certainly would be a valid way of doing it. But the nice thing about 45 and 15 is when I add them together, I get 60. And when I subtract them, I get 30. And they're both exact values as well. So I could rewrite that. Now, it's sine cos, so it must have come from the sine. One would be the addition of the 2 angles. One would be the subtraction of the 2 angles. So I get 45 plus 15, 45 minus 15. They are both exact angles that I know. I go, oh, well, root 3 on 2 plus a half. There's my answer, root 3 plus 1 on 2. It's a little shortcut, I guess. As I say, you don't have to know that formula. We have alternative ways of doing the question. But if you did know that formula, it could save you a little bit of time. All right, let's go back the other way. And these formulas really are just the reverse of the other ones. So how do I go from a sum to a product? But they're more fun to say. Right? Because it looks terrible, doesn't it? Sine A plus sine B. If I've got a sum, it's going to become 2 sine half of A plus B cos of half of A minus B. Well, that's no fun. That's much more fun. It's 2 sine half sum cos half diff. Right? So 2 sine half cos sum, half sum and cos half diff. There's the cos one. It goes 2 cos half sum cos half diff. 2 cos half sum cos half diff. And then we could have cos A minus cos B. This is the one that's a little bit different because it's a minus rather than a plus. So because it's a little bit different, I started a little bit different. So instead of going 2, I go minus 2 because that's a little bit different. So minus 2, and instead of going cos, which you think logically you would do because it starts with cos, you actually go sine. So it's a little bit different. It's just how my head works. You would not want to be inside here, trust me. It's just how it works. So I think, okay, 2 sine half sum cos half diff, 2 cos half sum cos half diff. That's for the additions. For the subtraction, then I'll go minus 2 sine half sum sine half diff. You'll notice there's not a sine A minus sine B there. And I'll do an example in a sec to show you why, because I can use those ones to do it. So we're going to convert it. So cos minus cos. Oh, minus in the middle. That's a bit different. So if that's a bit different, minus 2 sine half sum sine half diff. So the sum, 5 and 3 is 8 half of 8a. The diff would be 3 minus 5a, which is minus 2a. So I get minus 2 sine 4a sine minus a. Sine minus a, but sine is an odd function. So sine of minus a would be the same as, and there we go, 2 sine 4a sine a. Sine minus sine. Oh, hang on, didn't have a formula for that, but that's okay. I can turn it into the sum of 2, again, using odd and even functions. Minus sine 4x would be the same as plus the sine of minus 4x. So I can do that with the sine function because it's an odd one. Cosine I can't do that with, and that's why I need 2 formulas for cosine, because the negative and the positive are the same. So I need 2 formulas. Sine I can handle using the fact that sine's an odd function. So sine then would go 2 sine, because it starts with the same thing, sine half sum cos half diff. And there it is, 2 sine x cos 5x. Those of you who are paying really close attention will notice they're just the same examples I did before. I'm just going back the other way. Okay, so I had to solve this equation. Sine x plus sine 3x equals 0. Now, sure, I could rewrite sine 3x in terms of x's and do it that way, but this is much more fun. I can say, oh, hang on, I'm going to turn this sum into a product, and it's a sine one, so it'll go 2 sine half sum cos half diff, and now I've got a product equaling 0. So much easier to solve equations with products equaling 0 because we know the basic rule. You've got things that multiply together to equal 0. Well, one of those things has to equal 0. So I've got 2 sine 2x cos x equals 0. So either sine 2x is 0 or cos x is 0. And so we're just looking at the boundary values of the different trig curves. So sine, it would go 0. So you imagine the curve winding along the x-axis. We're saying, okay, where does it hit the x-axis? So 0, 180, 360. We've got 2x, so we're going around twice. So 540, 720. Got to divide by 2, of course, to work out what x actually is. Cos curve, not as much fun. It just goes 90, 270. We had to get 2 answers for that one. And so all up, I mean, some of those answers are the same anyway. We get 0, 90, 180, 270, and 360. All right, didn't put too many questions there, because as I say, not actually in the course as such. It's just a little bit of fun to have. So we'll just spend the rest of the day finishing off our trig.